name is Brian Boyd. I'm a sales director for Centroid System based here in Dallas, Texas. On the call today, we have Ranga, one of our solution architects on both Exadata and Exadata Cloud, and Mary Burcham also, who kind of coordinated a lot of this event today. So real quickly, we're going to be taping this, and then we will be asking questions at the end of the session. So if you have any questions, hold them, and then we can go ahead and ask those at the tail end of it. To real quick give you a little overview on Centroid. So we're a 20-year-old Oracle consulting practice. We have a deep history in Oracle engineered systems, along with the evolution into Oracle Exacloud, and everything in between as well. So today we're going to be talking about Exadata, unlock your existing investments if you have in Exadata, or if you're looking at Exadata, or you're trying to evolve that into different iterations of it and newer versions, etc. So at that, I'm going to hand it to Ranga, who's going to be doing the presentation. And again, if you can keep on mute until the end of the session, and then we'll open it up for questions as well. So Ranga, I'm going to hand it to you.
All right. Thank you, Brian. Good morning, everybody, or good afternoon if you're on the East Coast. My name is Ranga Sarvabalan. I'm one of the enterprise architects at Centroid. Prior to Centroid, I've been with Oracle as a pre-sales engineer on Exadata engineered system. Right. So my background has been Oracle technologies, primarily focusing on database for the first 15 years, and then moved on to enterprise systems and hardware. Right. Thanks for joining today. I'm going to make it quite easy. Right. We are going to be talking about customers who have installed Exadata, who have purchased Exadata for their different workloads, and now we're going to find out how you can maximize the current Exadata investment, or you're planning to invest on a new engineered system. How should you be going about in planning? What are all the options that you've got when you have got an Exadata system, especially as the capacity of the system has either reached, or the capacity or the load on your database workloads that are running on Exadata has reached? What are the options you've got, right? That's the primary focus of today's webinar. Okay. All right. So let's proceed. So it's a standard disclaimer. This presentation is primarily for education purpose and give you a bit of a guidance to see what path you've got to take in the future, right? Every customer environment is different. So, we would like to continue the conversation after this webinar once you're comfortable with the approach that we are undertaking towards whole of Exadata investment as well as the cloud journey. We'll be happy to have the conversation with you as well. So let's walk through the agenda today. We are going to talk about the current Exadata life cycle. What are the different types of workloads people normally consider to run on Exadata? When I remember way back in 2011, 2010, it was an ideal platform for consolidation of your databases. Right now, as different customers start to look at different technologies in the database world, Exadata system might be either overutilized or underutilized. The idea of this particular webinar is to talk about those as well. And what are the options have you got once you've reached that particular capacity? Okay, so end question and answers. Some of the bullet points over here. Most of the customers, I do not know whether you've got a full rack, half rack, or a quarter rack, or a 1/8 of a rack. 1/8 of a rack, I think, was introduced way back in 2012, 2013 timeframe, right? So, but most customers who are having a full rack capacity, as you could see, depending upon the age and the version of your Exadata, right? Starting from X3 to X7. Probably in the last 3-4 months, we have got X8 as well. I haven't had that in here, but if you're talking about the next 8, please feel free to add if you find anything different over here, right? So the objective of an Exadata prior to as I said, it's primarily for consolidation, given the fact that we have the secret sauce on the storage tier and the InfiniBand communication between your compute nodes and your storage cells made it a wonderful system to run massive data warehouse type of loads, right? Primarily, many customers I have seen have gone into the pitfall of running an OLTP against an Exadata, right? If their database workload is, say, 80% OLTP and 20% reporting type of queries, people have not utilized the bandwidth or maximized the benefit of running an OLTP-based system or an engineered system like Exadata, right? And we have had many success stories of customers running on competing engineered systems like Greenplum, right, moving over to Exadata or Netezza, right? So we have had success stories in there. It's an ideal platform for consolidation in that respect. And the performance metrics of an Exadata against some of the competing engineered systems, again, it's going to be varying depending upon workloads, but probably about 80% of the use cases have always, or the proof of concepts have been proven successful on an engineered system like an Exadata system, right? And most customers would ask the question, like, along with an engineered system, what would I like to do for my backups and my recovery? Customers have invested money on storage appliances like ZFS, and for near zero data loss, people have gone into ZDLR. Most recently, Centroid, I've got success stories of having customers running with both engineered system like an Exadata as well as with ZFS for their backup, as well as ZDLR for some of the critical applications as well. So let's talk about the current life cycle of an Exadata. What are the current state challenges, right? So probably you are running on an X3 or an X4 Exadata. So we are looking at that as now an ancient hardware. It's primitive hardware, right? And as the workload increases on those half rack or a full rack system, you've got the option of either expanding your Exadata investment, right? And then what do you do with it? Like, do you really want an engineered system to run multiple workloads on your half rack or a full rack, right? Sometimes as the business evolves, the data that is being pushed in terms of the velocity, meaning in terms of the speed in which the data is being pushed, and the variability in data also expands your database size, right? Rather than, a lot of limitations that are being enforced from standards point of view to limit your or retain your data for n number of period, right? And people have gone into archiving mode. An engineered system, probably, I think, starting from X4 onwards, we had this whole life cycle management of moving the data that are being unused to a slow performance disk, like spinning disk, rather than keeping it on your flash cache, right? The other possible thing is you've reached your capacity on your Exadata system, meaning you cannot add additional workload. And you might be thinking that having multiple workloads, certain workloads would require an engineered system. Certain workloads that you're running on an Exadata might not require the same benefits. Like, I touched upon something like OLTP-based applications. And sometimes these applications that are pushing data onto these on the engineered system might be thinking about, okay, what is the other option that I got? Do I still need to invest more money on my engineered system, or is there an easier option for the customer to move off for such a bulky hardware? All right. What Centroid pretty much what we do is we do on what we call an Exadata workload assessment, right? Here, it's going to be very interesting to see some of the statistics, right? So, as I said, we review the entire engineered system right from the version of the hardware, version of the software you're running, the capacity of your hardware, right? And engineered system do provide some standard SLAs, or what they call it as, maintaining your level of service. Okay, so we start off with having an baseline of your current hardware. Then we start looking at your metrics. And when we collect metrics on 5 key items, right? We talk about the CPU, obviously, I/O utilization, memory, and network speed. Now, the reason why we go down to that level of running an AWR analysis or AWR mining report, what we call it as, right? It gives us a good understanding of the individual workloads that is running on your engineered system to identify and categorize each of those workloads in terms of the ratio or the capacity utilization of your underlying hardware. Why it is critical is it gives us an avenue to classify whether this workload is required to have the features of an Exadata system. Like for example, some of your database workloads may not be a great benefit of using storage indexes. Could be like, making use of, I don't need column filtering, for example. You might be pulling off entire system. So we also speak about the application requirements. What does your application currently use, right? How does it filter the data? Do you pull all the information and then you control what information is displayed or sent back to the client inside your application? Then you don't need some things like column filtering. So that's the first portion of what we collect in terms of metrics. And one of the tools that we use to collect this information, apart from Oracle Enterprise Manager, we go a bit deeper to study the storage cell metrics. We talk about the IO metrics. We study the InfiniBand metrics, right? We do all the SAR report analysis. Most customers on engineered systems do have OS Watcher running on it. So we look at so we start mapping your workload with your hardware utilization, and we also start looking at mapping of the feature utilization of an engineered system. We first define, then we define that category, and that we fill that matrix first. Then that gives us the option to sit and then review our workload analysis and then to determine what actions do we have to take. Yeah. So what we do is we categorize each of these workloads into three categories: low, medium, and high, right? Along with the overall utilization of your engineered, the overall capacity of your engineered system. So when we categorize a sum of all your workloads, and if we say that, okay, you are using probably like more than 60% of your CPUs currently being burnt on the compute nodes, right? Then there is no point in two things, right? You cannot add additional workload to it because you're going to be impacting your service level metrics, number one. Number two is you cannot increase the workload on your existing database because it might going to impact it. So what options have you got? So you have to either start looking at archiving and purging of those systems, but sometimes it may not be viable an option. So what is the other? You can make room for that specific workload to expand by moving some of the other workloads that are falling into the category of medium and low, right? So we formulate this particular three-dimensional matrix where you've got your Exadata capacity. Then we start talking about the database utilization and features based on the metrics we are collecting, and then we are going to say, okay, what is the ideal workload that can either move off your engineered system so you can allow the existing workload to utilize and maximize your Exadata investment, or you can start talking about, okay, if instead of me moving into it, what is the option of siphoning off my Exadata workload onto something else totally, right? And now, what are the options you've got to move off your Exadata? There are many options. We will definitely talk some of them in detail over here. Okay. So this is the second step after we collect the metrics that we do, meaning we will try to align each of those workloads to your service level requirements. Okay. Some of the features that we have got within an engineered system is to put what we call it as instance caging. Some customers do use it extensively. Some may not be using it, right? Especially for smaller workload, you don't want to spend more than, like, say, four threads of your CPU, right? So you're going to then start using some instance caging around it, right? Then we can define hardware resource pools for specific databases. People have spent a lot of effort in using database resource manager and IO resource manager to make sure one doesn't step on each other. I mean, sometimes customers have implemented these resource manager in their engineered system, but still it may not be the optimal method of doing things. Okay, so we spoke about database resource and IO resource manager. right? Now, this way, by if some customers were not, if you were not implemented some of these resource manager tools, then one of your workloads is going to start stepping onto the other. So when we look at the flow, once we collect the metrics, once we assign these metrics to each of the workloads and try to identify which category they come into, right? And then we are going to start saying, okay, what options have you got within your engineered system itself to maximize your investment, right? How do you limit one from one workload stepping onto another workload? Now, once we do that, then depending upon the future, depending upon what's the plan for these particular workload, we've got different options in the to move some of your workload. The first option is obviously if you're running an engineered system, you really like the engineered system, you've got a great licensing model with the Oracle people, then you can always add a new Exadata or expand your current Exadata investment as well, right? That could be like, you can obviously span across multiple racks, or you can expand, scale up within an engineering within a rack itself. What's the downside of this? It's expensive, right? And you have to, there is some setup cost in terms of someone coming from OCS or from, folks like Centroid to come and sit in your data center for a couple of days or 3 days to set up your hardware and allow it, then give it back to you. The second option you've got is you can move some of the workloads onto a new commodity hardware, right, rather than an engineered system, right? And you can now, in the market, you do have the hardware resource metrics are pretty good, right? Some customers have decided to mimic some of the features of an engineered system by using commodity hardware. That is this other option that you got. What's the downside of that option is it may not be as powerful as your Exadata system, but by purely looking into a commodity hardware, the amount of hardware investment might increase so that you are trying to mimic your Exadata investment, but so thereby you are now increasing an additional capex and an additional opex as well for those systems. The other option you've got is to move to something else. I don't want to have my workload on Oracle database. Now help me to move off Oracle database, right? So probably you may not be investing for critical workloads. You might think that for non-critical workloads, you might think I don't need an Oracle powerful database engine like Oracle. I'm happy to live with something like MySQL or even a NoSQL platform in that instance. Again, this option does require some hardware changes, but there is a lot of application responsibility, and there is also a lot of changes to be made on the application and the whole business process as well. The simplest option is going for a cloud option, right? Again, depending upon whether you're choosing to expand your Exadata investment, that is on-prem, not a problem, safe, easy, but huge operational expenditures. Now, on an average, based on what we have seen to maintain a full rack, right, on an engineered system, apart from the capital expenditure, the OPEX has been around anywhere between $100,000 to $150,000 a year. That includes the power utilization, the power cost, the cooling costs, rack space, right? Then you must have an engineer to run your data center, to run your Exadata system. So it includes a combination of all of these variables and putting a dollar value to each one of this variable, it adds up roughly between anywhere $120,000 to $150,000, right? That is to run one Exadata rack, and obviously you can maximize that by running multiple Exadatas. But just to give you an example, that's the standard operating cost of an engineered system after you've purchased your capital, after you've invested on the capital of an Exadata system. Okay. Now, cloud provisioning is one option. And now, again, in cloud provisioning, customers do look at multiple cloud, heterogeneous cloud, right? Some customers would are more inclined towards AWS or Google or Azure. Some are inclined towards Oracle. But at the end of the day, you need to identify what is the right platform if I'm going to a cloud. So we will definitely touch on some of the key elements that you have to consider before making that move as well. And likewise for RDBMS as well. Now, Centroid has been helping customers. Centroid has been helping customers to do many of these things, right? We have not only an engineered system. We have been awarded multiple years for as the engineered system implementation partner. We've been awarded the cloud implementation partner for customers, right? And we have got different practices within our organization that helps customer to move off Oracle and think about a non like open source softwares as a database engine. Likewise, we have moved customers from open source onto an Oracle database as well. Now, specifically, I'm going to talk about some of the cloud strategies you've got. Right now, there is no better cloud provider to run your Oracle dependent workloads on Oracle Cloud Infrastructure. Now, the reason being that is it's not only from the support perspective, right, but the design of the core infrastructure inside Oracle, the virtualization is limits any request, and the source of a request and the destination of a request no longer will take 2 hops, right? The maximum it's going to take is 2 hops between a client request and your database request, or from an application server to your database, or from database to any other database sitting inside OCI, no more than 2 hops. That's all. The design itself is completely changed from the previous version of Oracle Public Cloud offering. So the OCI offers that. The network capacity between different rack units inside an availability domain has got a pipe of up to 25 terabits per second speed, right? Obviously, using the PaaS offerings from Oracle, right? It could be a database on a virtual machine, or database on a bare metal, or Exadata cloud service, or active data guard, or autonomous database, or autonomous workload for data warehouse, right? Your patching is all being maintained by and done by by Oracle itself. So meaning you are going to be running your database workload on an environment that has got zero vulnerability pretty much. Now, Oracle independent workloads, meaning if you identify some of your databases that may not be requiring as a powerful engine as Oracle, then you can start looking at some of the options that are available if you're interested to migrate off Oracle. Things like MySQL or Aurora or PostSQL, right? But then we do an evaluation of what is the effort that you need to spend in migrating your workload off Oracle onto any of these newer technologies, number one. Number two, we also help you to determine what should be the target shape and size of your footprint in whichever cloud provider you're going with, right? Could be AWS, or it could be even Oracle. You can still run Aurora and MySQL and OCI as well. Not a problem at all. We'll be happy to help you there. Here are some of the offerings that comes with Oracle Cloud Infrastructure around databases, right? So Oracle for databases, when we say offering, we talk about PaaS offering, right? So it comes in 4 different flavors. Apart from standard edition and enterprise edition, you've got 2 additional one, which is called as the high performance and extreme performance, right? A customer requiring a clustered database with active data guard pretty much go for an extreme performance. And some of the when we start mapping your database workload, we start looking at what features of enterprise edition you're actually benefiting out of it, or if you're not, then we can always pick and choose the model and the version of software on your target environment. Okay. Inside Oracle DBaaS, right, what does it offer, which is a PaaS offering? You can have a single instance database, you can have a rack database, you can have a single instance with active data guard, and you can also have a database rack with an active data guard. Now, this is if you're trying to move a workload into a PaaS offering. You can always, Oracle offers Exadata Cloud Service as another platform, so you minimize the change in the database behavior once you move into a cloud. That's one option. And for some of the OLTP-based applications, you can pretty much migrate off from an engineered system into an autonomous database, wherein you can choose your shape and size depending upon how much CPU power you need. you can pretty much go into an autonomous database. Or if you have a workload in a data warehouse, a workload, you can pretty much go into autonomous database, autonomous data warehouse workload option as well, right? The key benefit here is with going with an autonomous database as well as with an Exadata is the differentiator between the two is in autonomous, the scale up and scale down operation is going to be transparent to the customer, whereas in an Exadata cloud service, it is slightly different. Now, likewise, if I go with the PaaS offering, the scale up and scale down operation, whether in terms of additional storage or additional CPUs, right, it is transparent. It is on the fly. You don't have to you don't have to stop your database from servicing your applications. You can do it on the fly. It's unlike other cloud providers method of saying scale up, scale down operation is online because they stop the workload pretty much on one machine. They create another big machine and then attach the storage to that. That is not the way in Oracle it works. Okay. Now, the reason why I have this particular chart up here is to tell you that to advise customers that, like, depending upon the shape of the machine, you get different network interface cards that comes attached to your virtual machine or your engine or your bare metal server. Why it is important is when we start looking at your workload and when we start determining what kind of IO metrics it is consuming, we have to choose the relevant type of shape in Oracle Cloud that will match that workload requirement, IO requirement especially, right? So there are two things we have to talk about IO. One is the throughput, the other is the latency of these workloads, right? So we know what throughput is, we know what latency is. The reason why we are emphasizing here is no matter whether you have a provisioned IOPS, right, unless otherwise there is a guarantee in terms of latency for multi-block reads or single block reads, your database is going to have a massive impact when it comes to performance and servicing. So Oracle has thought about this, and all of the DBaaS offering on the cloud, right, offers exactly the different flavors that you can choose to match not only your CPU but also your IO requirements. Now, running an Exadata cloud service is pretty much exactly the same as what you would be doing it on-prem. The only difference there is, like, you have to, it's a subscription based model, right? And your scale up scale down operation have to be a planned approach. And some of the Exadata cloud as a service offering, it is exactly this. As I said, it's the same. Performance is always met. You've got the newest version of Exadata. You've got the newest version of Secret Sauce, which is the storage software that is running on it. Right? It supports different platform versions of database, as long as it's 11.204 and above, up till now 18C as well. Right? Some of the secret behind Oracle's newer offering on Exadata Cloud Service is your autonomous database and autonomous data warehouse service. The differentiator there is both of the autonomous versions of database and data warehouse runs the underlying platform that they run on is an Exadata system. And depending upon which option you're choosing, right, you might have certain type of access. For autonomous, you are not going to gain access to the underlying compute or underlying store itself. Whereas for an Exadata quarter rack or a half rack, you would have that same kind of benefit as well. Now let's start looking at the cost benefit analysis when you're looking at Oracle Cloud. Right, Oracle offers a very flexible licensing options. Especially how to maximize your current licensing model, and if you're planning to bring it over to Oracle Cloud. If you want to take it to an other public cloud service and still run your Oracle database and other public cloud service, you have to be very careful in terms of what is sitting in your current licensing agreement with Oracle and support agreement with Oracle, and then choose the right option. Also look at the ongoing support cost and maintenance of running your Oracle workloads, be it on OCI or be it on any of the public cloud. Consider that. We do a benefit analysis in terms of saying, okay, based on your workload analysis, the option you've got, and based on your security requirement, and based on other limitations that are there for your organization, sometimes it could be ideal for us to invest money on an additional hardware. So we'll then allow you, we'll be happy to give you multiple options whether you want to increase your Exadata or look at some commodity hardware and then give you the migration cost as well. Okay. So we spoke about operating expenditures as well. This is very important, multi-cloud optimization. It is very important. All of our competing public cloud providers have got a unique selling point to run certain types of workloads. But enterprise type workloads running on an Oracle database, ideal on an Oracle cloud infrastructure. Some non-enterprise or non-critical workload that does not benefit the value of an Oracle strong RDBMS can benefit from running it on another platform like MySQL or Postgres. Then we can always look at having a different cloud provider offering that as a service, and Central will be happy to help you to maximize how to invest on and how, when say invest, how to keep the size and shape of your underlying virtual machine that runs these software as well. Now, what are the options that a customer has got in order to move to Oracle Cloud Infrastructure? One standard thing we talk about is database export and import using data pump, right? Now, I say it's ideal for databases that are less than 2 terabytes in size, where the database can be up and running within 24 hours, right? Beyond that, we cannot go down this particular option, right? Using a data pump and using data pump gives the flexibility to reorganize some of your database objects in itself, right? The other option is backing up your Oracle database from your on-prem to Oracle Cloud Storage and then restoring or initiating your database on the cloud based on that particular storage. The key differentiator is here you can have it in sync. You can keep taking your incremental backups, pushing it to the cloud, and then keep restoring it on the cloud. Then once you are satisfied that everything is up and running on the cloud, you are able to connect. You can able to quickly review whether you've got all your changes being applied. Then you can flip the switch. The other option is transportable table space. Centroid, we have done multiple migrations to Oracle Cloud Infrastructure using transportable table space, especially for customers who are coming from a non-Linux environment. When I say non-Linux, it could be Solaris, it could be Windows-based databases as well that we have moved them onto Oracle Cloud Infrastructure using transportable table space. Obviously, when you're running, if you're on-premise pluggable database, right, if you're using multi-tenancy or you're on-prem, right, then it becomes easier for us to move to a new, to Oracle Cloud Infrastructure as well. The other option that the customer has got is having a data guard environment in Oracle. That many customers use this option as their DR, as one of the DR functions for their database workloads running on engineered systems. People have said, okay, I want to have a DR for my one workload in OCI, and I'll make it as available now, depending upon whether they want to have a regular standard Oracle data guard or it could be an active data guard, depending upon whichever option they choose. They pretty much have got their toes dipped in Oracle Cloud Infrastructure. They review the performance of some of their queries, especially if you're using active data guard. Once they are comfortable, they immediately flip the switch to go to cloud. The other option is purely from consolidation perspective, and I'm saying consolidation is because Golden Gate can be ideally be a tool, especially when you're migrating multiple databases to a single database target environment in Oracle Cloud, right? Within a single database workload shape. So we have implemented Golden Gate. We also use this option to help customers to move off a different operating system, like, as I said, Solaris and Windows platform. And for very large databases, like, when I say very large, where in your capacity, where your database size is like 170, like 200 plus terabytes, for example. If that is the size of your database workload, And if you've got enough downtime, it could be one of those archive databases or could be for financial reporting of holding data, which is going to be sitting there for next 7 or 10 plus years. We use the data transfer service. Now, we have helped a large entertainment company to move close to about 7 petabytes of data from their on-prem onto an Oracle Cloud Infrastructure solution as well. Now, what are the considerations you've got to do from the application side for each one of these various options you've got, right? So, one thing is trying to always, when you're planning to move some of these workloads or increase. Now, if you're increasing your investment on your current engineered system, not a problem at all. But if you're planning to move onto a cloud or even to a new commodity hardware, think about where you want to place your application servers closer to the database. So we suggest you to move when you move your database workload off your premise and moving onto a cloud, move it along with it as well. Move your application workload also to the cloud service, right? When you choose your cloud provider, pay very close attention not only in terms of the operating system version, the CPUs and the networks. The reason why I'm saying we've got to pay very close attention is sometimes a 1 vCPU is equivalent to a zero point 0.5 OCPU in OCI, right? So there is an additional cost implications of running it on, say, 24 vCPUs, wherein you've got to, where it is considered as 24 processor based or 24 thread based licensing cost, as compared to choosing your cloud provider like Oracle, which will look at 24 vCPU as just 12 OCPU cost. So think about, you've got to pay very close attention. Also pay very close attention based on the network capabilities and IO capability. I showed you an example of the network latency as well as the network bandwidth that is available in OCI. So choosing your right platform and choosing your right hardware shape is very important, whichever cloud provider it is. Okay, so we spoke about the thread cost and the vCPU comparison to Oracle OCPU. Right. So this is what we call it as an Exadata assessment work. Right. So this is what we do. We analyze each of those workloads. We sit with you. We talk to you about what is the option, what is the future holds for these workloads, and we'll give you some options. Right. And if you're looking at cloud migration, we'll be happy to take part in it. As I said, we have been the implementation partner for cloud OCI implementation for 2018. Last year, we got that award during Open World. We'll be happy to do it. What are the further analysis that is required, right? Advice we always tell customers, especially when database administrators are really running off and putting off spot fires, right? Create a fingerprint for each of your database workload, right? Categorize them, how much of CPU it is using. Continue to maintain some kind of a metrics that is going to help you to evaluate those upfront, right? Try to understand a bit more from the database angle, from the application, rather than from a database angle, but from a solution angle. What is the dependency for my application, right? I mean, does my application need to keep grabbing multiple records when it is actually going to be displaying only one record to the customer? Try to have a conversation with your application developers to say why they are doing certain type of queries against your database, right? And again, solution, when we are mapping each of the workloads to different options you've got, look at your provider solutions. What is that they have out of the box? Is it worthwhile for me to run Postgres cluster by myself, or can I go as an offering? Is there an offering? Is there a provider that is able to give me? Or if you're going for Mongo or a NoSQL platform, look at the sharding capabilities that comes out of the box. Look at the replication capabilities that comes out of the box, right? So you start thinking about that. These are some of the analysis that is required if, I'm stressing this again, if you're planning to move your workload off your Oracle onto something else. What does Centride offer? We help you to prepare this fingerprint of each of your workload, right? We speak to your application people. We review the queries that are being executed based on different categories. When I say different categories, it's not only in terms of the execution time slash elapsed time. It could also be the volume of those particular queries. It can also be how much of resources that it is consuming. We start looking into those. Sometimes you'll be surprised that when a SQL type of query consumes enough high resources, we can come and there could be some analysis that could be made in the way in which that segment has grown. So we can introduce some newer method of trying to siphon the data by consuming the least amount of network resources as well. We do a blueprint of what are the candidates that are ideal to move off your engineered system, whether this particular workload was utilizing some of the engineered system features, yes or no. We will talk about what are the security requirements if you are planning to choose your future map of going towards cloud. We will talk about that as well. We do the migration planning. Our migration planning for customers will follow the standard SDLC model, right? Meaning we do a proof of concept. We spend some time with your team. We do the migration, we open it for testing, we look at the lessons learned in it, we advise some of the automation tools that are available like Terraform and Ansible that are available for you to speed up your migration as well. So we do that quite extensively. Obviously, some applications like Oracle EBS, right, or JD Edwards, or some other workloads that are pretty much running on Oracle Linux, right, or a Linux-based solution, it's easier for us to do a lift and shift as well. Centroid has got, we used to run a campaign which was like, I think 5 days to migrate, lift and shift one workload to Oracle Cloud Infrastructure under $5,000 with a limitation of no more than 10 terabytes in size. So we used to have that. We are running newer promotions around lift and shift. We look at the overall picture about how your Oracle or like Amazon or Google, what will be your overall footprint, how much vCPUs or OCPUs you need to require, what kind of storage you're going to require. So we will try to help you to map your operational expenditures on each of these cloud services. We have seen many customers burning again of moving into a cloud platform and losing control in terms of their cloud bills every month, right? So we limit that as well. We are an organization. We follow the sun. So we offer 24/7 managed services support for your cloud as well. We also engage our offshore team to help us to do this migration, especially for customers who want to reduce the migration days right to a cloud platform. So we engage our offshore resources as well. So that is at a high level of the whole webinar today, right? And I've got 15 minutes of time. I'm going to open up for any questions. Brian?
Yep, I'm here.
All right. So we'll just open up for questions. I'll be happy to answer, or if they're going to share the information with you via email, more than happy to get back to each one of these customers, right, with a detailed answer as well.
So does any customers have any open questions that they wanted to ask about Exadata or, how we can help you out? Are there any trends or anything else that, you have questions about in regards to this open line? All right. Appears not. Again, I guess I'll wrap up then. Again, we provide a wide range of services. Again, as you can see on the screen, IT consulting, managed services. We do licensing consulting. Again, we've been in business for 20 years, have over 200 full-time people on our staff across the world. if we can do anything to help out, please don't hesitate to reach out. And if you signed up in the forums, we'll send you a follow-up replay of the seminar. Again, every customer is different. Some want to go to Exadata because they've done certain calculations. Some are on it, an old version, want to go to a new version. Some customers want to get out of the data center business. Every customer is different, and every situation is different. We're happy to help you out, evaluate what's the best thing for you as a solution, make good recommendations, and tie those things to a sound cost of ownership solution profile. So with that, we'll wrap up. And again, thank you everyone for your time.
Thank you.